Good afternoon, everyone. I'm here to speak on Group B, Project Sprint 2. We'll be looking at regression analysis, the most powerful technique to predict success in a Major League Baseball. My name is Alex Enaboye, the project analyst, and with me are two provision data scientists, Bianca Pujobasi and Adam Grayton. So the presentation is going to go in 6 content. Our introduction will be looking at the yearly baseball data visualization, which has been an important direction in the field of information visualization. And in this project group, we'll be using linear regression predictive model and correlative analysis to forecast the future with baseball data visualization, analysis, and statistical comparison in order to draw a conclusion out of our analytical finding and to meet our business need. So we'll summarize the state of our project into 3 important aspects. The first one is data types and extraction. The second one is data visualization technique. The third one is statistic analysis. But firstly, we need to look at the baseball summary and understand the composition. Major League Baseball consists of 2 leagues, the American and the National. Each league has 15 teams and 3 divisions. The session lasts for 162 games. The winner of each division advances to the league division championship, and each team have a minimum of 25 players on its active role, and we have the statistic measurement to determine the performance and the rate, and we have the batting average, we have the runs in, bat-in, home runs, on base percentage, and sluggage average. Project objective is in 2. The project Sprint 2 objective is straight to 2 parts. The first one is to determine if the team are more successful at offenses, tight offenses, or the balance of the 2. The second one is to determine if the conclusion will be valid across the multiple period. We have 4 periods before 1920 to 2010. The business objective is in 4 ways. The first one is to develop an econometric model to explain the factor that drove the baseball. The second one is for the forecaster to have a working model which will be used to predict future with business orientation. The third one is the baseball management should have a solid foundation in which a policy decision is made based on the business need. And the third one is a strategy for future in order to reduce costs. And we have a problem statement analysis. The business scenario is to hire a general manager to rebuild a team that has a long losing record and worse over a period of years. And the business problem is not determining of independent variable. The success of the team are called the period due to change, low budget, and we'll be working on 2 dependable variable, offensive and defensive variable. The decision variable is an outrun based on the winning percentage, and we have a defensive input which is of offensive trade and defensive trade. So I'll be handing over to my data scientist Priyanka. Thank you.
Thank you, Alex, for providing such a nice introduction and the business questions. To be able to answer the business questions as outlined by Alex with a high accuracy, we must first of all frame the analytical objectives. Our main objective here is to build a regression model to predict the future success or win percentage of a baseball team. In order to get into that point, we need to perform a thorough step-by-step exploratory statistical data analysis. Statistical analysis enables us to understand the statistical properties and distribution shapes of different key variables present in the available dataset. From the shape of the distribution of the individual variables, we can easily predict which variables are most vital to be considered for the model building for future prediction. In step 1, we execute the data cleansing process to confirm that the dataset is complete and sufficient for our intended analysis. Then we need to process the datasets for selecting the training and test datasets for our regression analysis, as well as to do the correlation analysis between an independent and a dependent variable to verify which variables are the most useful for our analysis. In the next step, we must perform regression analysis for model building. There are several steps to execute in regression analysis, which I will discuss in the following slides. Once our model is built up, we need to validate its performance and accuracy, then we can accept and use the model to answer the business questions. Now I will discuss about these steps in detail. Our main tool to perform the analysis is the Python programming. For data processing, we will first install the required Python libraries in Jupyter Notebook, and then we will read and define the data file as shown here in this slide you see. So now the next step is to go for the regression analysis. But before moving forward to do regression analysis, we will do the correlation analysis between the variables. Since baseball is so number heavy, there are many different variables to consider when searching for the best predictors of the team success. So we all know that in data for baseball performance, there are offensive and defensive attributes. So here in this slide, I have presented just the two data sets, two independent variables and dependent variables, and made the correlation analysis between them. There are several other variables to do the same analysis, but as an example, I just have shown the two of their values. So here we can see that from the first analysis between runs scored and games owned, the Pearson correlation coefficient value is 0.596. So that means like if the Pearson correlation coefficient is closer to 1, the stronger the relationship is between the two variables. So here we see it's almost like more than 50, like 0.5. So it's a strong correlation between these two parameters. Also in the bottom we can see that the runs scored minus runs against and the games won, the relationship between these two parameters are also like very strong because the correlation coefficient is 0.850. So using this analysis, this correlation analysis, we can select like which attributes are strongly correlated, and we can just select all those attributes for our next analysis and to be used in the regression model. Once the variables are initially selected from the correlation analysis, a preliminary regression equation will be fed to the data in Python. I will go into details in the regression analysis. Now, if we ever need to create a forecast, then regression analysis is the best. But why? This is because it runs very fast, very easy to use, very high accuracy, and easy to interpret. Now we will learn the core principles of regression and how to use it to predict the winning percentage of the baseball team. So the most important parameters in regression analysis are the variables, covariance, and the correlation. And now I'm going to see that I'm going to show you the regression equation. So the first one, y is equal to mx plus b, is the simple linear regression, and the second one is the multiple linear regression. So here y is the dependent variables and x is the independent variable, and m is the intercept. The m is the slope and b is the intercept. So this is the general regression equation for any kind of regression analysis. I will go directly to the Jupyter Notebook to show you how to do the regression analysis using Python. So here we see that at the beginning, for doing the regression analysis, we'll need to train our model using the training data sets. So in order to do that, we'll train the data sets, and we will use all the attributes. We'll not delete anything here. So on the basis of all the data sets, if we train our model, we see that there are standard errors in which assume that the covariance matrix of the errors is correctly specified, and also like there's a very small eigenvalue that might indicate that there are strong multicollinearity problems or the design matrix is singular. Now after doing this preliminary analysis with our model, we see that from the above that the 28 columns have very high p-values here, which is the most important factor to validate our model. So we see that there are several factors which have 0 p-values, but many other have higher p-values, more than 0.005. So in that case, like from there, we will see that we fail to reject the null hypothesis for these columns, meaning there is no relationship between these columns and the games won. So in our next model, we'll try to remove a few of those columns and see how the model performs. So now I will do the same kind of analysis, but now we will remove the attributes from the model. So the attributes which have higher p-values. So in order to validate our hypothesis too. So now we will move forward for different time frames as specified by in this project. So but we will keep removing the high p-values attributes, and we will slowly narrow down the number of attributes. So now after all those analysis for different time frames, at the end for the fourth model, we have come into the conclusion that there are a couple of attributes which have very low p-values. So we can see that the f statistic, the probability f statistics is a very important parameter for any kind of model building using regression analysis. So it should be very close to 0. So here we can see that from our model the probability f statistics value is is 0. So it is rejecting the null hypothesis, which means our overall model is very significant. Now we have only 8 columns, and even out of these 8, the 5 rest are also insignificant because they have high p-values. And based off our adjusted r squared value, we see it's 1. So if it's close to 1, it means that the model is performing better than all other previous ones, because there are the values are less than 1. So now we have our final model. Now we need to proceed for the model validation. Is another important factor to do in case of regression analysis, because it tells you how perfectly fitting your model for any kind of analysis, or how best it is to answer the business questions. Model validation, if we go to the Jupyter notebook, and now if we do the analysis to predict the games won for the New York Yankees team using the model, we see that for this team in 2012 the actual number of games won was 95, but the predicted value for that for using our model is 94.9666. So that means they are very close to each other. So this actually validates that our model is perfectly 100% fitting to the actual value, and it can be used for future predictions for this kind of games performance, or to guide the teams on which basis we need to perform in the team to secure our success. Adam will discuss the rest of the analysis and the outcomes of the model, and he will conclude the talk today.
Thank you, Priya. Using our model, let's see how it does predicting the performance of the New York Yankees and the Toronto Blue Jays. Our model is trained only on data from 1990 to 2010. However, we will be predicting games won in 2012 and 2015. In 2012, the New York Yankees won 95 games, and in 2015, they won 87 games. Our model predicts that they would win 94.97 games in 2012 and 86.97 games in 2015. The predicted games won is nearly identical to the actual games won. Now for the Toronto Blue Jays, in 2012, they won 73 games and 93 games in 2015. Our model predicts that they would win 72.99 games in 2012 and 92.99 games in 2015. Again, the predicted games won is nearly identical to the actual games won. Based on our prediction analysis, it can be said that our model's performance is exceptional. Let's now look at our model's RMSE score to judge how accurate our regression model is. RMSE stands for the root mean squared error, and is calculated by taking the square root of the mean of the squared errors. Using Python, we calculated that the RMSE of the New York Yankees Game 1 prediction is 0.03, and the RMSE of the Toronto Blue Jays Game 1 prediction is 0.007. An RMSE score less than 0.1 means the model is performing exceptionally well. With both RMSE results less than 0.1, we can confidently say that our model is performing exceptionally well. Our business scenario asked how a new general manager should build their baseball team for future success. Should they focus on offensive statistics, defensive statistics, or a balance of both? Using historical baseball data, we developed a regression model that could predict the future winning percentage of a team, and identified the features that drive the overall performance and the team's success. By performing predictions and calculating the RMSE of our model, we confirmed that our model performs exceptionally well, and the 8 features used in the model are the ones that a team should focus on to increase games won. Based on our analysis, it is the balance of offensive and defensive statistics that drives a team's performance. Using the regression model that we developed, we can confidently advise the general manager that they should focus on building a team that has a balance of both offensive and defensive capabilities. Thank you.